So now we're going to talk about arithmetic sequences specifically, both the definition of as well as the recursive formula for these types of sequences. So an arithmetic sequence is simply put something where there is a constant difference. For instance, if you were looking at a sequence 5, 8, 11, 14, you should notice that each time it is increasing by 3. So we'd say the constant difference, usually referred to as D, would be equal to 3. Now there are cases where it's not going to be readily obvious what the constant difference is, but if you take a term and subtract the term before it, this is where the constant difference comes in, then you'll get what that difference is, in this case a positive 3. If you do that for any other terms, for instance 14 minus 11, you'll get that same constant difference. Now, and this is a sequence, so when we're looking at this, we also know that 5, 8, 11, and 14 are the actual terms. We call them A sub n, where n refers to the number. That is, we typically always start counting at 1, which means 5 would be the first term, 8 would be the second term, 11 would be the third, fourth, and so on. Now this does mean it keeps going, which means at some point down the line, there's what we call the nth term, which means that that term, that nth term, whatever it may be, the actual value would be a sub n. Now, this is going to require a little bit of thinking, but the term beyond the nth term would be called the n plus 1th term, which means that the value of that would be a sub n plus 1. And working it logically the other way, the term before n would be n minus 1, and the value of that term would be a sub n minus 1. This is going to come in very handy when we start talking about, well, recursive formula. So recursive formula, key word here, key part of this word I should say, is recur. In an arithmetic sequence, what is recurring? Well, the constant difference. So if we're looking at a constant difference of, say, 3, then we know that that is an arithmetic sequence that is going up by 3. Now, there could be a bunch of arithmetic sequences that go up by 3. However, we had a specific one in mind last time, and that was when the first term was equal to what? 5. So if you have the first term defined as well as this difference, then you've got that sequence defined, whoops, 8 plus 3 is 11, not 13, 14, and so on. Now, what this means is we have the value of each term as well as the term number. So the value of the first term is 5, the value of the second term is 8, and so on. Now, if we want to write what is called a recursive formula, we want to talk about what is happening over and over again. In this case, the d equals 3, we're adding 3. So at any given instant, if we have a term, we're adding 3 to get the next term. So we have term plus 3 equals the next term. Now, we don't use this notation because we know that, for instance, and this is where it kind of comes in very important, for any given term, let's say n and a sub n, remember that, and often, and your book will do this, they'll say n plus 1 and a sub n plus 1. What we're going to do is define what's happening to go from one to the other. So, to figure out what a sub n plus 1 is, that is what our next term is, we have to define it in terms of the term before it, which would be a sub n, plus whatever that difference is. So in the case of this particular term, we're talking plus, sorry, this particular sequence, we're talking plus 3. Now, you may be saying to yourself, well, wait, we have this difference, but that could be any sequence. We do need to include the fact that the first term is somewhere. Now, usually we say it's the first term, so when we talk about a recursive formula, there are two parts to it. In this case, a sub 1 equals 5, and a sub n plus 1 equals a sub n plus 3. That tells us the constant difference as well as what the first term is. It is possible to define an arithmetic sequence in terms of the constant difference. That's got to be there. But you could use a different term. You could say a sub 10 is equal to whatever it is equal to. As long as you have one value of the actual term, then you're fine. So remember, a recursive formula must include the difference, as well as at least one term. And we usually include that a sub 1. And this is the notation that we'll use for that.